Hi, my name is Barish Baduri. I'm 17 years old and I'll be a senior at Farragut High School this fall.
Alright, so as a solution to Data Challenge 7, I chose to use a database known as Resource Description Frameworks, or RDFs. So what RDFs are graph databases used in the semantic web to create relationships between data items so that they can be interpreted computationally, but also human readable. So what I did to create these RDF files, or graphs, using the datasets that the Data Challenge provided is that I created these PostgreSQL tables. And so I created one for clinical trials, one for participant data, and one for as a link table. So I rearranged the data given in the dataset and turned it into a CSV file and then stored the information into each PostgreSQL table. Then, using the D2RQ database, I used the generate mapping and the dump RDF commands to create a RDF file, which is this shown right here. So using this file, I uploaded it using Virtuoso and created an RDF graph, and that is right here. And so all of that is data representation, which was all in challenge question 1. So in response to challenge question 2, which was the algorithm, I used the Sparkle query editor of Virtuoso, and I wrote this query, which then matched each patient with their clinical trial match based upon the cancer site of the patient matching the cancers that the clinical trial treats, and the performance status of the patient versus the minimum performance status requirement of the clinical trial. And as you can see here, patient 6, 9, and 10 do not match with any of the 50 clinical trials in dataset 3 according to these stipulations, but I wanted to show that this algorithm works even if and it's not just an error. So if you don't take into consideration the performance status, all 10 participants match with a clinical trial of some sort. So that's the solution to the challenge question number 2. And challenge question number 3 was data visualization. So RDFs can form these graphs, and these graphs can help visualize the relationships between each data item and another data item. So these triples are now related and can form a more complex structure, which can lead to more human comprehension.